Dividing architecture into modules and measuring it in relation to their multiples and submultiples is a practice that has always characterized the history of architecture for both compositional and constructive reasons. Dimensioning and proportioning are therefore essential aspects even in the context of hypothetical reconstructions, and considering them from the initial stages of the work up to the publication of the digital model is crucial. In hypothetical reconstructions of architecture from the past that aim to be scientific products, it's vital to adopt a repeatable, transparent, and easily shareable method. Thus, sizing the model by identifying the correct unit of measurement and proportioning it based on rigorous modularity allows to rationalize the reconstruction process and to simplify its production, documentation, and sharing. Naturally, this approach is legitimate when it's plausible that the architect used the module and the unit of measurement in the first place. Often, the sources do not directly mention the unit of measurement or the module originally used. Nevertheless, it's possible to deduce the units of measurement by considering the historical period and geographical area of reference, and the module based on the architectural style or the construction system. For example, masonry buildings can be modulated starting from the dimensions of the brick and the bricklaying, or architectures that make use of the classical order in accordance with the Renaissance treatises are generally modulated with the diameter at the base of the column and its multiples and submultiples. The column diameter and the brick, in turn, were sized based on the units of measurement used in the period and geographical area of reference. Before adopting the metric system in Italy, the use of foot was popular. Its measure could be slightly different from town to town. For example, the Bolognese foot was about 38 cm, while the Vicentine foot was about 36. Studying the proportioning of architecture based on a deduced or known module can also be conducted on an out-of-scale drawing. However, in hypothetical reconstructions, it's highly advisable to start from drawing scaled with the reference units of measurement, as the module itself is dimensioned starting from it. For illustrative purposes, we consider the case study of the 1685 project for the Church of Santa Margherita in Bologna by Agostino Barelli. First, the drawing was scaled starting from the available graphical scale of 10 Bolognese feet. As said, the Bolognese foot was about 38 centimeters and was divided into 12 ounces. Subsequently, the width of the Corinthian pilaster was identified as possible reference module, which was equivalent to 2 feet and 3 ounces, about 85.5 centimeters. Based on this module, the proportioning of the entire architecture was then hypothesized. For example, the central nave corresponded to 8 modules and 4/6 of a module, which corresponded to 19 feet and 6 ounces, approximately 7 meters and 41 centimeters. The proportioning and scaling were verified with some dimensions reported by the architect. In cases where neither the graphical scale nor any dimensions are available, it's possible to verify the scaling on known elements, such as the risers and treads of stair or the height of doors. However, this method is more uncertain and should only be considered when no other alternatives are available. Proportioning architecture based on a module and not just the unit of measurement has not only a philological value, but also a practical one. It allows for identifying a rule to compensate for potential alterations typically present in sources subject to deformation, such as paper. Moreover, it helps simplifying the redesign phase and makes documentation more transparent. Adopting rigorous modularity and clearly communicating it will allow future scholars to repeat the procedure and obtain comparable results. In a digital context, it's advisable to convert measurements from the historical reference system used for preliminary proportioning to the metric system, as not all contemporary software packages allow for the use of archaic units of measurement. Furthermore, using the metric system allows the operator to more easily control the redesign. When using CAD applications, it's also crucial to model at the correct scale from early stages of work, as this has implications for the precision of measurement, which always refer to the certain tolerance imposed by the software. Choosing a scale that forces using excessively large or small measures could cause defects in the model. Such defects can only be corrected by starting over at the suitable scale. A popular misphrasing when talking about digital modeling is that the 3D models are made at a 1:1 scale. However, it would be more appropriate to say that measurements are reported without any multiplication or reduction factor, as in architecture, the concept of scale is closely related to the level of detail of 2D and 3D printing. There are many different standardized scales for the level of detail used in various contexts, such as those used for building information modeling or CTGML. However, to communicate clearly and simply the level of detail of a reconstructive 3D model, it's sufficient to refer to the maximum scale at which the digital model could be 3D printed without loss of detail.